Hi everyone, Tina here, and today I'd like to talk about the chain rule, the product rule, and the quotient rule for differentiation. You'll usually come across these topics during year 2 of your A-level course. I have made other videos on differentiation, so I'd recommend you watch those ones as well. I'll show you the rules and we'll go through an example of each one. Let's start with the chain rule. Chain rule says dy dx is equal to dy by du times du over dx. What we're doing in the chain rule is we're taking the dy dx and we are splitting it up. Dy stays on the top and dx stays on the bottom, but they've now been split. And we're filling in the blanks with du. This works because the du's effectively will cancel each other out. So this here is the chain rule. There is a special case of the chain rule, and that says that dy dx is actually the same as 1 over dx dy. And that works because dy dx times dx dy would mean that the dx's cancel out and you get dy over dy, which is just the same as 1. Now let's look at an example that involves the chain rule. Example 1. Given that y equals x squared plus 5 all cubed, find dy dx. Now the chain rule is useful for differentiating functions within functions. Here we have a function within a function because we have x squared plus 5 within the cubed. So we're going to set it up like this. Y equals u cubed, where u is x squared plus 5. If we then differentiate each of those separately, dy du is just 3u squared and du dx is 2x. Chain rule then says that dy dx is equal to dy du times du dx. Remember, because the du's cancel out. And then all we need to do is times those two expressions together. So 3u squared times 2x. That simplifies to 6u squared x, but that's not our final answer because we need to replace the u with the expression that we said it was earlier. So final answer will be 6x and then x squared plus 5 squared. And that's because we've replaced the u with x squared plus 5 again. Just to recap, this was an example of the chain rule because we used the chain rule here. Now let's move on to the product rule. So the product rule says that if you've got a function that looks like this, y equals uv or u times v, then to differentiate it, dy dx equals v times du dx plus u times dv dx. This is something I would recommend that you memorize as soon as possible. So because of the way the function looks, this tells us that the product rule is actually useful for differentiating two functions times together. Hence the name product. Let's look at an example where we'll need to use the product rule. So example 2, given that y equals x squared times root 2x minus 1, find dy dx. So we can identify that we need to use the product rule because we can see here that we've got two separate functions multiplied together. We'll need to call one of them u, so let's say x squared, and the other one v, root 2x minus 1. Now, because I know that I'm going to need to differentiate v at some point, I'm just going to rewrite it as 2x minus 1 to the power of a half. Writing it in that form will make it easier to differentiate. Du dx we can do straight away, pretty straightforward, is just 2x. But to find dv dx, we might actually want to do a chain rule on the side. So by this I mean literally draw a line down the side of your page so that the working is completely separate, and then use the chain rule to work out this derivative. So if we say y equals u to the power of a half, where u is 2x minus 1, then we can work out this derivative. So dy du would be a half u to the minus a half, and du dx is just 2. Remembering that chain rule says we just need to multiply those two things together. So dy du times du dx, in this case, is going to be a half u to the minus a half times 2, which is just u to the minus a half. Remember to replace the u at the end. So that's going to be 2x minus 1 to the power of minus a half. So that's using the chain rule there. And then we can take the output of that chain rule and go back and use it in our product rule. So let's put that as dv dx in the product rule. Now, over time, you may develop your confidence and be able to do that step in your head. But in the meantime, doing a chain rule on the side is totally fine. Once you have all of your expressions, you're ready to substitute into the product rule. So dy dx is v du dx plus u dv dx. Once again, this is something we need to memorize. And then we just substitute in the algebra. So nice and easy, just replace all the terms accordingly. Unless the question specifies a format to leave the answer in, that's okay, but I would probably just tidy it up very slightly, put the 2x in the front and keep the x squared in the front there. And that's our answer. Finally, let's look at the quotient rule. The quotient rule says that if you've got y is equal to u over v, then dy dx is equal to v du dx minus u dv dx all over v squared. This is the quotient rule here. Looking at the format of y, you can see that the quotient rule is useful for differentiating two functions that are divided by each other. Hence the name quotient. Now, interestingly, you are given a form of the quotient rule in the formula booklet, and it looks like this. This version is in terms of function notation, so things like f dash of x, g dash of x to represent the derivative. I recommend that you just use this as a backup and actually that you try to memorize the version that's got u and v in it at the same time as memorizing the product rule. This will be much quicker for you long term. Let's look at an example involving the quotient rule. So here you can see we've got y equals 3x over 2x minus 1. Two functions divided by each other. That's a hint that we would use the quotient rule if we wanted to differentiate it. Reading the question in full, the point P lies on the curve with this equation with x coordinate 1. Find an equation of the tangent to the curve at the point P. So the fact that we want an equation of the tangent means that we're going to want to differentiate so we can find the gradient. So let's use the quotient rule to find dy dx. Now it's important that you set u always to be the top function, so 3x in this case, and v to be the bottom function. We do du dx, which is 3, and dv dx, which is 2. And then we apply the quotient rule. So dy dx equals v du dx minus u dv dx all over v squared. And that's quotient rule here. We now sub in our components. So that's going to be 2x minus 1 times 3 minus 3x times 2 all over 2x minus 1 squared. If you expand the top, you get 6x minus 3 minus 6x all over this, which simplifies to minus 3 over 2x minus 1 squared. You can expand the bottom if you want, but I'd probably just leave it because I know I'm going to substitute a number in the next step. So when x equals 1, dy dx is going to be minus 3 over 2 times 1, take away 1 squared, which ends up being minus 3. And also when x equals 1, if you substitute into the original y equation, you'll get 3 times 1 over 2 times 1 take away 1, which ends up being positive 3. So that comes from just substituting into the original equation. Now that we know all of that information, we're ready to find the equation of the tangent by using y equals mx plus c, for example. Substituting in all the relevant values will give us this, means c equals 6. Therefore, full equation is y equals minus 3x plus 6. And there we go. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.